And welcome to learning for the use of the properties of similarity to solve problems. Please make sure you put your name, your period, and your number on here as well as the date. If you're watching this at home and you don't have a paper for it, you can find the paper in the back of 1029, or you can write it out by hand and be able to hand it in that way. What is the symbol for similarity? Well, this is actually one that we need to actually look at carefully because we're used to congruent, and congruent is an equal sign with the squiggly line on top. It's equals, but it's exactly equals. The similarity is just a squiggly line. So if we were to say that two triangles are similar, this is what we're looking for. We're putting this symbol, not a congruent statement, which means that the two triangles aren't exactly equal. That means we're telling them that we're proportional. Write what needs to be congruent and what can be proportional when we compare two figures. The angles are congruent, and the sides are proportional. So even though the side lengths are different, the actual measurement of how wide the sides are from each other happens to be the same. So even though when we're looking at doing the measurement, it doesn't matter how long the legs are or the sides of the angles are. The measurement and how wide they're open is the same. However, how long they are proportional. So if we're looking at how to write a ratio, we're looking at two things. We're putting it, usually it's written as 2, 2, 3. And if we were to say 2 green boxes to 3 red boxes. So that's one way to write it with our 2, one to write it with our colon. But the most productive way to do it is we're doing 2 green boxes over 3 red boxes. We're going to be putting that, and we would list it as 2, 2, 3 without our units. So we're looking at this as a fraction, but we should know that when we have the 2 on top, it's referring back to the green boxes, which is the first number, and the red boxes here, 3 is referring back to the second number here. We need to make sure that when we line these up, these understood units are with it. What's the difference between a ratio and a proportion? A ratio is one fraction. A proportion is two fractions set equal to each other. So one fraction like 2 to 3 is equal to 4 to 6. This is a proportion. This is a proportion. And sometimes we can leave out one of these numbers and we can find it by cross multiplication. But a fraction is just 2 to 3. A ratio is just one fraction. So when we're looking at this here, these are two similar figures. They have, it should say in the directions here that they're similar, but I'm going to just tell you that they're similar, and we're going to find for the side x. So when we do this, the opening from here and here is exactly the same. So when we do that, as well as here and here, they're the same. So when we have these angles are the same, we can set these up as a proportion. So we can do this as 5 over 9, this side over this side. And the reason I chose the 9 is because the x is on the bottom as well. 12 over x. So when we figure these out, sometimes they're turned or they're different ways, but they are exactly looking at these. We're putting these together and we're configure these out as a proportion. So when we do that, we can cross multiply. So we have 5x equals 9 times 12. 5x equals 108. So now 5 times x should equal 9 times 12. It's another way that we can check something is proportional. If we know x, it can be 5 times whatever x is equal to 108. So we're going to divide both sides by 5, and our x equals 21.6. 21.6. So this right here is 21.6. So this, which makes sense, 9 is a little bit bigger than 5. 12 is a little bit, or excuse me, 21.6 is a little bigger than 12. They should be in relationship. It shouldn't be less than, because 5 is less than 9, but 12 should be less than 21.6, or the other way around. 9 should be a little bit more than 5, and 21.6 should be a little bit more than 12. So it should make sense when we put it back into our picture. When we're looking at here in this proportion, we have a great big triangle and we have two parallel lines. This right here means parallel. So we can compare these two sections and set them up as a proportion. This little thing right here is the parallel. So when we look at this, we can set this up as x over 16 equals 5, top over bottom equals top over bottom. Well, if you can't, looking at this is a half, so we can see if we're looking at this clearly that this should be 8, because 8 over 16 is half, 5 over 10 is half. But let's cross multiply to check. 10x equals 5 times 16. 10x equals 80. Divide both sides by 10. We can see that x equals 8. So when we're doing this, the part about this is we don't want to get stuck in a formula. Because if we get stuck into a formula, we're really in some sorry shape. We have to think it through. So what we're looking at is, how do we put this together? There's really one wrong way to do that. If we put the 10 over the x and the 5 over the 16, we really have to put them so that they match up. X and 5 are together as a reason as the top, and x over 16, this also means that they're on the same side. So if we were to set this up, another way to set this up would be x over 5 equals 16 over 10. And the reason we put the 16 on top is it's comparable to our x. And we put the 5, so it's just like what we're putting in our picture. These are connected, these are connected. We can't switch the 10 and the 5 around because these aren't in proportion to each other. No, that's a no. So if we cross multiply on here, we get the same exact thing that we had right here. So if you want to set it up this way, you can, or you can set it up the first way, and both ways solve our problem. Another proportion, another way to do this is if this line segment right here is a bisector. It is a bisector. It bisects this angle right here, where both angle measurements are the same. We can see that in here. So this angle A is cut directly in half, but it doesn't guarantee that this is the midpoint. We can't say that that's the midpoint. What we can say, though, is what it gives us in here. CA is 18, CD is 24, BA is 11, and BD is our unknown. Because this is a bisector and these two angles are equal, we can set this up as a proportion. I'm going to put this question mark as X. So when we do this, we can do this again. Either put 11 over 18 or 11 over X. I like it this way because I can see it. 11 over X. It kind of looks like two proportions, equals 18 over 24. We cross multiply. 18x equals 24 times 11. So we have 18x equals 264. Divide both sides by 18. X equals 14.67. So this should make sense. It should be less than 24 because 11 is less than 18, and it should be more than 11 because 24 is more than 11. So this is more than 11, but less than 18. When we're looking at number 8 in here, we're looking at the perimeter, and in number 9, we're looking at specifically the area. Specifically the area. So when we put this together, we're looking at, we have a ratio right here. See our ratio? That's our little dot dot. So when we can put this together, we can put our 2.6 as a side. It doesn't matter which side, but I'm going to choose this one. And this one is here is 9. So we're going to set this up, and we can set our proportions together in here to be able to put this in a, to solve for the perimeter here. 2.6 over 9 equals, the perimeter for 2.6 has to go on top. We're going to call that x over 36. So we have 9x equals 2.6 times 36. 9x equals 93.6. Divide both sides by 9. X equals 10.4. Again, this perimeter should be less than 36, but more than 2.6 to see that we've done it correctly. The last one I want to tell you about is the area. So area is the same thing. We're going to do a proportion, but it has one special thing. We have to, area equals squaring the sides or the ratio. So let me tell you. So we're going to draw a picture of what we have in here. We have two triangles, A, B, C, R, S, T, and they tell us one side length is 3 and the other side length is 2, and that the area for triangle ABC is 27. ABC, so the area here is 27. So when we put this together, we have 3 over 2 equals the area for the triangle that has the side 3, which is 27, over, and this one is unknown, we're going to call that x. So this is our normal proportion that we set up, but because we know the area is squared, we have to square both sides here. So we have 9 over 4. 3 times 3, 4 times 4, or excuse me, 2 times 2 equals 27 over x. Cross multiply on here. We have 4x equals 108. Divide both sides by 4, and x will equal 12. That's our area. The area equals 12 square inches. All right, good luck.